Hello guys. I'm next Gerson E. Nuevo, and my section is C1115, and the subject I'm doing mathematics in the modern world. To analyze the data set in Excel, start by organizing the values in ascending order for easier interpretation. Next, calculate the mean using the average function, such as equals average parentheses b6 b59 parentheses. Placing the result in a separate cell for reference. Once the mean is determined, compute the deviation of each data point from the mean by subtracting x from each value in the data set using equals b6 minus sfs1. Where sfs1 contains the mean, this formula is applied to the entire column to get deviations for all values. To eliminate negative values and highlight larger variations, square each deviation using equals C6 to 2, ensuring consistency in the statistical analysis. Finally, sum the squared deviations using equals sum parentheses d6 d59, which is essential for variance and standard deviation calculations. Now, moving on to analyze ungrouped data in Excel. We start with prerequisite values, the total number of data points, um, n is equals to 54. So the sum is equals to 9,830. So the max is 280, and the mean is 103, and range is 177. This help in calculating key statistics. For central tendency, the mean is found by dividing the total sum by n, giving 182.04. So the median is the middle value of the ordered data, so 172, via Excel shortcut. The mode is the most frequent value, 117. For dispersion, variance measures how spread out values are, calculated as 2811.81, and standard deviation square root of variance is 5303, showing average variation from the mean. These calculations are verified using both Excel formulas and shortcuts to ensure accuracy in ungrouped data analysis. To solve this problem in Excel, start by organizing the data into a group data table, so which includes class intervals, frequencies, and midpoints. The histogram helps visualize the data distribution, and the frequencies values from it are essential for calculations. So the first step is to compute key values such as the product of frequency and midpoint, as well as the product of frequency and midpoint squared. These values are necessary for further statistical analysis. Next, let's move on to the descriptive statistics table. So let's find the descriptive statistics table. So here it is. So the descriptive statistics table is completed by calculating the mean, median, mode, variance, and standard deviation. The mean is found by dividing the sum of the frequency multiplied by the midpoint by the total frequency. The median is determined using the formula for group data, which requires identifying the median class and using values such as the lower boundary, cumulative frequency before the median class, frequency of the median class, and class width. The mode is found using the mode formula for group data. Variance and standard deviation can be computed using either Excel functions or standard formulas. After computing the descriptive statistics, the prerequisite values must be determined. So this involves identifying the median class and um, computing necessary values like the lower boundary, total frequency, cumulative frequency before the median class, frequency of the median class, class width, and an adjustment term. These values are then used in the Bayesian formula to find the final result. So, to implement these calculations in Excel, use formulas to compute the required values. The frequency multiplied by the midpoint is calculated using a simple multiplication formula. The sum of these values is obtained using the sum function, which is then used to find the mean. So similarly, other statistical measures can be calculated using predefined Excel formulas or manually applying the respective formulas for group data. So by following these steps, the group data is properly analyzed and important statistical measures are accurately determined. So let's move on to the simple linear regression. So to calculate the Pearson's correlation coefficient, simple linear regression line, and coefficient of determination. So using Excel shortcut, start by organizing the X and Y data into two columns. Select an empty cell and use the formula equals correl range 1 and range 2. So to compute the Pearson's correlation coefficient, where range 1 and range 2 represents the X and Y data ranges. So the result will indicate the strength and direction of the relationship between the two variables. Then next, for the simple linear regression line, use the equals linear y range and x range through and through function, which provides the slope and intercept of the regression equation. Alternatively, you can create a scatter plot by selecting both data columns, navigating to the Insert tab, and choosing Scatter Plot. Once the chart is inserted, add a trend line by clicking on the plotted data points, selecting Add Trend Line, and enabling the display equation on chart option. So, this equation represents the simple linear regression line to determine the coefficient of determination. So, r to the power of 2. So, ensure the display r squared value on chart option is selected in the trend line settings. The r squared value helps assess how well the regression model explains the variation in the data. These calculations and visualization provide insights into the correlation and predictive accuracy of the regression model. So that's all for today, guys. So thank you for listening and watching, and goodbye.